Okay, so today we are going to learn, it's similar, we're still proving triangles are equal, but we're going to use something called corresponding parts of congruent triangles. So when we do this, what we're going to be doing is, just like in the first proof we want to prove that BC is equal to DC. And so we won't be able to prove that any other way other than first, at the top underline, proving triangles congruent. So that's the first thing we're going to do, is prove that our triangles are congruent to each other, just like we've been doing by SAS, SSS, ASA, or AAS. And then the second thing that I'm going to do is, once I prove the triangles are congruent, I'm going to prove that their corresponding parts are also congruent. So that'll be the second thing that we do. So with each of these proofs, the first thing I'm going to do is prove that my triangles are equal. Once I do that, I'm going to use a on the right hand side, I'm going to use something called CPCT, which stands for corresponding parts of congruent triangles. So with this first one, first step is going to be my given statement: AB is equal to AD, and AC bisects angle bad. So again, the first thing I'm going to do is look through my given statements, my written given statements. AB is equal to AD, so AB and AD are equal to each other. And then it says that AC bisects angle bad. And so again, if an angle is being cut in half, that means that angles are equal to each other. Oops, this is my given. And so with my second step, I'm going to say that, again, angle bad is this angle that goes all the way from BA to AD, so that big angle right there. And so I know that this big angle is going to be cut into two equal angles, so this angle right here is going to be equal to this angle right here. So my second step is going to be that angle BAC is equal to angle DAC. This is going to be by definition of an angle bisector. I've got two things equal, so now I'm just looking for one more thing, so I'm going to look at my picture. I should be able to see that AC is common in both the left and the right triangle, so I'm going to say AC is equal to AC by the reflexive property. So that's my third thing. So now I can say my triangles are equal. The one thing that we have to work on that we haven't had to do, oops, mark my sides here. One of the things we have to work on is figuring out whether our triangles are a reflection or a rotation. So with this first problem, or with this first example here, if we look at it, triangle BAC is being flipped over onto triangle ACD. And so this one is going to be right by the picture, if you could put reflection. And so I know that I'm just going to, if I'm visualizing this, I'm going to flip this triangle over top of the other, and so all the points have to correspond. It matters the way that I write these triangles. So if I call the first one triangle ABC, I've got to think about which point A is going to flip over onto. So A is going to flip over onto A, B is going to flip over onto D, and then C is going to flip over to C. So I know that triangle ABC is equal to triangle ADC. I can look at my picture. I've got two sides and an angle. And so if I look, these two sides, the angle's in between the sides, so I'm going to do SAS. Again, the sides, here's my angle, here are my two sides. The side intersects where the angle happens at. Be careful though, I'm not done yet. I want to prove that BC is equal to DC. And so with my last step, I can say that BC is equal to DC. And if I look at my picture, BC and DC, when I would flip the one triangle onto the other, they would be on top of each other. And so they are corresponding parts of triangles we prove congruent. So we can put down CPCT for corresponding parts of congruent triangles. With the second one, same thing. I'm going to write down my given statement first. I can tell by just seeing that AB, I'm trying to prove that AB is equal to CD. I know that my last step is going to be CPCT, so that's kind of one of my hints. I've got E as the midpoint of AD, and angle A is equal to angle D by my given. So with my second step, E is the midpoint of AD. So AD is being cut in half by point E, so AE is equal to ED. Oops. Again, I use the same word, so definition of midpoint. I've got angle A is equal to angle D. Oops. Mark my sides, mark my angle. Remember to use that picture to help you. So I've used all my written given statements. Now I want to look at my picture. It's a bow tie, so I know I'm going to have vertical angles in the middle. There we go. So if I wanted to name those angles, I go angle AEB is equal to angle CED by vertical angle theorem. And so again, it's important for me to figure out whether this is a reflection or a rotation first. For me to get this angle on top of this angle, I can't flip it. I'm going to have to spin it, and so this is going to be a rotation, which means that I have to twist the entire thing. So I'm going to grab the thing and I'm going to rotate it actually 180 degrees to be over on top of the other one. So when I'm naming these, I've got to make sure I name them the correct way. So if I'm going triangle A, E, B, again, I know that when I spin it, A is going to end up on D. So my next one is going to be D. E is going to end up being on E. And then angle C is going to, angle B is going to end up on angle C. So AEB is equal to angle DEC. Again, if I look at my picture, I've got two angles and a side. Here are my angles. There's my side. So the side's between the angles, so I know that this is going to be by angle side angle. Remember, I'm not done. I want to prove that AB is equal to CD. So I can go 5. AB is equal to CD. And I know this because, again, AB, which is AB, and CD, or when I would rotate it, they would be on top of each other, so they are corresponding parts, CP, of congruent triangles, CT. Last two on the back page of the notes. Again, E is the midpoint of CD, and CD bisects AB. So with my first, if E is the midpoint of CD, so if E is the midpoint of CD, I know that CE is equal to ED. CE is equal to ED. Again, use the same word, so I'm going to use the definition of midpoint. CD bisects AB, so if AB is being cut in half by the other line, I know that BE is going to be equal to AE. Again, this is going to be by definition of a segment bisector. And then looking at my picture, oops, mark it on my picture that those are equal to each other. And looking at my picture, it looks like an hourglass. So I'm going to know that these two angles are equal to each other. So with number 4, I'm going to say that DEA, angle DEA, is equal to angle BEC by vertical angle theorem, VAT. Fifth step, again, my triangles are equal to each other. Should be able to look at this and see for AE to end up on EB. I can't just flip it down. I can't flip it vertically on top because they wouldn't end up on top of each other. So this is going to be another one that's a rotation. And so when I name it, I got to make sure I'm naming it with each point rotating on the other point. So if I name the top triangle AED, let's see, AED. Name the other one BEC. Oops. Triangle BEC. Because A is going to correspond with B, E is going to correspond with E, and D is going to correspond with C. Now look at my picture. I've got two sides and an angle. It's going to be SAS. Then with the last step, again, I want to make sure that I want to prove that angle A is equal to angle B. So angle A is equal to angle B. I know it because angle A and angle B are going to be corresponding parts of the triangles that I just proved congruent. Corresponding parts of congruent triangles. Okay. And then the last one, I've got two right angles, and I've got AP is equal to BQ. So first step is my given statements. Angle APB and angle BQA are right angles by my given. And I've also got AP is equal to BQ. Whoops. So AP is equal to BQ. And then I want to prove that APB, and BQA are both right angles. Don't really look like right angles, but whatever. So, when I do this with my second step, if I know that APB and BQA are both right angles, I know that angle APB is going to be equal to angle BQA by definition of right angle. So to look at this, so I've got an angle and a side, and then this is one that kind of has an extra little segment in there. So if I proved that this triangle right here was congruent with this triangle right here, A and B would be it'd be a reflection, and so A and B would be corresponding parts. And so with my third step, I can see vertical angles here. So I can say that angle ACP, oops, oh yeah, I do have a C on there. ACP is equal to angle QCB by vertical angle theorem. So I've got three things. I'm going to name them. Again, this one is going to be a reflection. So if I can think about just taking this yellow triangle and flipping it over onto the purple triangle. So when I name them, I'm going to name them accordingly. So I'm going to go angle, triangle ACP is equal to triangle A corresponds with B, C corresponds with C, and P corresponds with Q. I've got two angles and a side. So when I'm naming this, I've got angle, and then the side is not between it, so it's going to be AAS. And then with my fifth step, again, I want to prove that angle A and angle B are equal to each other. And so I can see that angle A and angle B are corresponding parts of triangles that I proved congruent. For my fifth step, I'll say CP, CT.